Hello, this is Dr. Ron England here, and I'm doing this recording for my Programming for Engineers class. It's a little question that they've been working on in Python, and some of the students were kind of stuck. And the reason I think a lot of students get stuck in the programming side of this is because they're trying to eat the entire elephant at once. There may be some confusion about different types of concepts within the programming language that they're not completely sure on, and then that just develops a level of uncertainty, and in the end they're like they can't even do anything. So this is the trapezoidal channel problem, and the reality of this, and this can work for any type of equation, but the equation that we're doing right here is we've written a function that returns the flow in a trapezoidal channel using Manning's equation, given, in this case, the n, which is the Manning's n, the b, which is one of the slope parameters, z, which is a slope parameter, s, which is a slope parameter, and y, which is the depth. Those variables. So in other words, those variables get passed over. And by the way, the fact that they're listed here as NBZSY and here as NBZSY, in fact, that's confusing. Let's call them something totally different. A, we'll call B B, since it's B. C, D, and E. Okay, now, down here you notice that if you look really close, that N has got a little underline as an error. That's actually because it's A in the globals. Z's got an error there because that one is going to be C, because that C corresponds with the Z, which would be there. And then the S in this case is D. Okay, in other words, they're different numbers altogether. Now, if I do this, if I highlight that and hit Control Enter, all those numbers get entered as into Python. Those are actually variables within Python. If I do this, if I take this function that I've written and Control Enter there, it's going to basically put the function into memory. And if I go over here and I do the print the trapezoidal Q, it's going to actually call that function with the parameters that I passed. Notice that now the parameters that are called something here and the parameters that are called something here inside the function, they're not the same variable names. And I know that confused people. They're like, oh, well, if you called it A here, it's got to be called A here. No! No, 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 no. This variable n is scoped to be n within this function. It is independent of anything outside that function. It does not exist outside that function. Now, the fact that you may declare a global n out here, which is basically if I put an n equals 0.022, that would be a global n. That doesn't have to match with this n. That is independent of this n. That is a different n. It is a global n. Okay, get it? The variables that you put right here only exist right in here. Now, if you were to declare a global variable out here and you were to use it inside this function, okay, it would exist. It would have the value that you gave it out here. But that would be a bad thing to do because you really want to have the variables that are inside of a function only live inside the function with those variable names. Okay, I'm going to repeat that because it's really important. These variables only exist inside this function, and variables that exist outside the function here should not exist inside the function. You should not have global variables being used inside of a function. The function should be independent of everything to the outside. Okay, hopefully you got that. Now, here's the question. This basic function here, which is a fairly complex function, calculates the flow in a trapezoidal channel given these parameters, the most important of which being this y, which is the depth. Now, if I want to know the flow, okay, I want to know the depth for a given flow. There's a bunch of different ways to do this, but I'm going to do the basic hand method. Now, I would never do the whole thing by hand because I'd write an iterative solution because I'm a programmer. I can do it really quick because I can make the program do all the work. But right now, I'm going to do some of the work myself. So I'm going to set these values. I actually don't even need the Q. So I'm going to set these values, Control Enter. I've already done this once, so I don't need to do it again, but I'll do it again. Control Enter. I'm going to go ahead now. The function lives inside of memory. The variables live inside of memory. And I'm going to call the function. Calling the function means I can pass parameters like the A here will correspond to the N here. The B here will correspond to the B here. The fact that they got the same name doesn't matter. I'm going to put a 1 in place of Y. Oh, 1. I'm putting a number, not even a variable. It's a number. I'm going all out now, putting a number there. The C corresponds with the Z. The D corresponds with the S. So in other words, whatever the value of D is, which is 0.01, it's going to be called with that value. And that value, when it gets over inside the function, is going to be used at the S variable inside of here. So now, I'm going to go ahead and take this. I'm going to go Control Enter. And if I bring this up a little bit, you can see that the value returned was 25.9. Now, I'm looking for the depth where the flow is 50. That's the depth. 1.0, 1 foot, gives me 25.9. Well, that's not 50. What can I do? I can try a different number. So let's try 2. All right, I do 2. Control Enter, and voila, it gives me 105.4. Well, obviously, 1's too low, and 2 is too high. Okay, that's pretty straightforward. So what should we try? Well, you know what? Let's try 1.5. That's halfway between the two, right? That's not a bad guess. Let's do that. Ooh, I'm getting close now. 57.95. I'm pretty close. All right, well, it's between 1 and 1.5. We know it's between, in this case, 1 and 1.5 because 1 was too low and 1.5 was too high. But looking at this, I'm going, you know, I could probably guess a little bit smarter here because it looks like it's closer to 1.5 than it is to 1.0. So let's try 1.4. You know, let's go down 1 there and see what we got there. Control Enter. Ooh, I am really, really close. 50.379. I'm getting really close there. But you see what I'm doing? I'm narrowing down on the solution. Now, the computer could do this too. That's what that other function that you see there is, where it calculates the error between the two and it changes the increments. That's just a way of saying, let's figure out how to intelligently iterate down. Okay, and there's a lot of methods to do this, and the one that most people use is the good old Newton-Raphson. This is called the I'm just going to guess till I get it method. Okay, let's go with 1.39. I'm just kind of, again, guessing there, and let's see how close we get. Control Enter. 49.65. Okay, so good. I know I'm now between 1.39 and 1.4. I'm going to go 1.395. I don't know how close that's going to be, but maybe it's really close. 50.01. Well, I'm close enough for government work now. I mean, I could go down a little bit more, maybe guess down to 1.394 and see how close I get with that. 49.94. Okay, well now I'm going to go 3.945, and I could just keep at this all day. I'm gonna, you know, I'm gonna narrow down 49.98. I mean, 0.02. I'm close enough. Point being, big points from what I just showed you here. See these variables up here? Those variables, those are not the variables inside the function. I know I've seen students get this confused. It's the concept of scope. These variables live inside of this function. Okay, these variables are global. They actually can live inside that function too. But if a variable like b exists outside the function and the variable b lives inside the function, they're not the same b, and the one that is declared in the function is the one that will be the b inside the function. There is a way to make the one outside the function be the one outside the function. But you shouldn't be having variables that are global living inside of a function anyway. So I'm not going to tell you how to do it. Other thing being, when you're calling this variable, which is the A right here, which is the global, same one that's right here, has this value, that's going to get passed over to the function, but when it gets inside the function, it's now called n. It got the name n because that's the when it is inside the function. These are standard concepts of programming, but you also saw my trial and error method, and hopefully this will help you out for some of the people that are really having issues with some of the concepts here. Notice I did not go into the iterative technique here. I've got another lecture that does all that. I want to get through the basics first. Thank you very much, and get out there and program.